Hello, I'm very welcome. When we did Neco practical, biology practical, it was really good. I felt it because when I saw the questions, I was happy that the things I thought were the things that Neco gave in the question, in the examination. So that was good. The questions, as I looked at it, that it would come out. That was how it came out. That onion bob I drew. The other ones, the vertebra, though this time they gave them, instead of posterior, they gave them anterior view of the lumbar vertebra. And other things, dicotyledons and monocotyledons. So those things I thought came out. And that was really good. That was really good. I was happy seeing that. So now this time I decided like chemistry. This one is also very important. If you follow us from the beginning to the end, you will learn a lot. So this is part 1 of this. This is on volumetric analysis. Volume. Look at this question. So we are going to solve this from question A to D. Join us till the end, please. Don't forget to subscribe and share this video. If you like it, you know what to do. Thank you. Now, I decided to cut it to remove part of the questions that are not relevant at this moment here. Because this quantitative analysis, that is volumetric analysis, titration, has to be done in the laboratory. But there's a way we do it most of the time. So the teacher can prepare the reagents, and you have to titrate acid against base and get your endpoint. But this time, what I know you find difficult is how to tabulate and do the calculations. That was one thing many students found difficult in alternative B, chemistry practical, WAEC 2024. They found it somehow difficult to answer the questions, especially on the water of crystallization. I discovered that it was not that I could do because that was the examination. No, I had to keep quiet. I even saw 0 as an answer. I wept. Students from other places, you know, it's a combined examination. Students from all the different schools came together at a particular examination. I saw 16.6 water of crystallization. That's now. Let me show you. And this time you also have sodium tetracarbonate 4. The value of water of crystallization of Na to CO3 is 10H2O. If you solve it, you see 10. The answer is 10. So how did they manage to get 0? How did they manage to get 16.6? That was wrong. So the answer is 10. And I hope that this time Neco will not ask you to calculate water of crystallization from this. Now let's look at this. I don't want you to fake, please. Let's do it. I will do this. This is the first one. I will make efforts to do the second one and the third one so that we become perfect at this. So that any direction that they may bring the question from, we'll be able to get it. Please follow me. If you're a teacher, you have to learn what to teach your students. Please. Alright, thank you very much. Alright, so now the question says A is a solution containing 0.038 moles per dm cube of concentrated surface acid. Right? So B is a solution of anhydrous sodium tetracarbonate 4. Then calculate it will tell you add, titrate against other questions. I decided to just take these ones and move into the questions. So there are other information that are supposed to be here after this. So that other information. Then these are the questions. So now we are going to make a table. Now, your volume of pipettes. Your volume of pipettes is 25 now indicator. The indicator here is what? Methyl orange. Why do we use methyl orange as our indicator? Why do we use methyl orange? Reason. This is a strong acid. This is weak as a base. So strong acids, the suitable indicator for strong acid is what? Methyl orange. Strong acid, strong base. Suitable for strong acids, methyl orange. That is indicator. Now we have the table. Alright, we have final. You can still write this or you leave it, the same thing. Alright, but this is representing it in the 2 ways. So you can just write final here. Then if you don't write, this is representing it both like this and like this. So final, because final bullet reading in this, then initial bullet reading, then then the average volume of acid, average volume of A used. You can include it there, or you leave it like this. So now, then our initial here is 0.00. When you perform, you start from, this is your bread like this. So from here to here, maybe 50 cm cube is 50 cm cube. Alright, so we have this calibration. So you have it 0, 0 here. So when you titrate it, against this base, alright, so you are going to, this is 0, you can have a 24.00. Then in the second one you can have 10. This is not permanent, it depends on, two schools cannot get the same values of table. Even 2-3 students cannot have the same values of initial and final. You can vary it. Second one, when I did the exam in secondary school, I used 0, 10, 20. I can remember. I planned mine that it should go like that. So let me still repeat 0.10 and 0.20. So let me use exactly what I did when I was in secondary school. What I did was C. Very good results. Alright, so now, so this can give you 34.50. This one, okay, 0.00. Then I will give you 20.00 rather, 10.00 rather, 10 and 20, 0, 10, 20. Alright, so this one can give you 44.50. Alright, so now let me make this one 24.40, 34.50, 44.50. These are the values you may have. So when this minus this will give you what? 24.40. This minus gives this 24.50. This minus this will give you what? 24.50. So our average volume of acid, average volume of A, that is A, used is equal to first plus second plus third over 3. That is first theta, second theta, third theta. Alright, so we have what? 24.40 plus 24.50 plus 24.50, all divided by 3. So when you add, let's clean this part of the board. Okay, we are going to use this. So what do I do now? Let me clean here. So we'll finish it. We are going to use this information to answer the other parts. Alright, so let me clean here. So now, when we add these, we get, I want to show it to you. So we have 24.40 plus 24.50 plus 24.50 is equal to 73.40. 73.40 divided by 3. So if I divide it by 3, I will get 24.46. So this is my 24.46. This is my average volume, average volume of acid of A used. That is acid. That is 24.46. Write the unit. Alright, so we have gotten this now. We have gotten this question number A. We'll move to question number B. So for question number B, after I've taken this, I would like to clean this now, because we are through with this table. Unless there's something you want to write. But I think we are through with this. This is just like the first part. So remember what I said. It does not mean that you have this as the exact value. You may carry out this experiment to get 22 points. So it depends on the concentration of acid. It depends on how the teacher prepared the acid and the base. Alright. Okay, let's get it down like this. Down like this. Before now, we used to have rough. We used to have rough, first, second, and third. But now it's first, second, and third. So things keep changing. It's not bad when you have rough first, second, and third. It's not bad as long as you can take the three that are very close and do not differ by 20, by 0.2 or thereabouts. All right. So let's solve this one. Concentration of B in moles per dm cube. So let's find this. Concentration of B. So for concentration of the base, this is the formula we use. So let me write the equation first. Let me write the equation. H2SO4 plus sodium triisocarbonate 4. Let me educate you a little more. When an acid reacts with a triisocarbonate 4, you have salts, corresponding salts, water, and carbon dioxide will be liberated. When you add acid to any substance that has CO3, normally effervescence will occur, and odorless and colorless gas evolves. It will turn lime water milky, and if you have litmus paper, it turns wet blue litmus paper red weakly, showing that it's a weak acid. CO2 is weakly acidic. It's an acid anhydride. So when it dissolves in water, it forms acid. So when you add acid and this, normally what you are going to have is salt, Na2SO4, water, and carbon dioxide. This is what you are going to obtain. You have salt, water, and CO3. So because of CO2 and acid, learn this. So like now in WASI, WAEC this say they gave them something HCl and this. In the alternative B, we were given this, but the question when it came out like this: Na2CO3 XH2O. So they decided to like add water of crystallization to it. I say something like that. So I hope that does not happen this time. I'm not sure it will happen. So this is what they are going to give us. Alright, so now from this, now look at this formula. CAVA, concentration of acid, volume of acid over concentration of base, volume of base, equal to number of moles of acid over number of moles of base. Alright, so now we are looking for the concentration of base, concentration of B alright, but the concentration of A is already given to us, 0.038. So let's state our parameters. Ca is 0.038. Va, a volume of acid, is this 24.46. Concentration of base is what we are looking for. Then concentration of base is what we are looking for. Rather, volume of base is volume of pipettes. That is size of pipette. Size of pipette, as we wrote that time, 25 cm cube. So write 25 here. Then what else? Number of moles of acid. Where is the number of, this is the acid here. It's 1. There is 1 here. So if you have something like 2, it means 2 is 2. Alright? Number of moles of base is also 1. So we can fix all these and get our answer. So Ca 0.038 times Va 24.46 divided by Cb times Vb is what? 25, equal to 1 over 1. So when we cross multiply, so 25 times Cb, okay, let me write it like this. Cb times 25 equal to all these, 0.038 times 24.46. So Cb is finally 0.038 times 24.46, all divided by 25. So when we get the answer, like us to write it here so now let's multiply. Do it with me. 0.038 times 24.46 is equal to 0.92948 divided by 25 is equal to 0.038. The answer here is what? 0.038. That is concentration of B in moles per dm cube. This is the answer for this very one now. Alright, so we got 0.0337, sorry, 0.0371. So 0.037, sorry, 0.037. Okay. Now we are moving to the next one. The mass of sodium tetraoxosulfate 6 that would be formed in solution if 1 dm cube of solution B were neutralized by solution A. Mass. This is supposed to give us something like mass concentration. Molar equal to molar concentration times molar mass. But we are looking for mass of sodium tetraoxosulfate 6. That is this. Mass of this. That's very good for us. 1 mole of this produces 1 mole of this. So they have equal number of moles in form. So they can go like that. So let's get 1 mole of that as under normal circumstance. Can we clean the board? Let's clean this place now. Since we have gotten our CB, but I will leave this CB because we are going to use it. Alright, because it concerns, this question concerns B. So we are going to use it as well. Alright. So first of all, the first thing we need to find here is the molar mass of this sodium. So sodium tetraoxosulfate 6. Find the molar mass. This 2 times sodium is 23. 2 times 23 is 46 plus sulfur is 32. 4 times 16 is 64. So if we add all these, I think is it 140. Okay, let's say 46 plus 32 plus 64. This was 142. Yes, this is 142 grams. All right. You know we are looking for mass of sodium tetraoxosulfate 6, right? That will be formed in solution if 1 dm cube of this. Let me change this marker. 1 dm cube of this. So we are going to use this now. We are going to use this value to calculate the mass of sodium in this 1 dm cube of solution B. All right. So this is B now. 1 mole of this equal to 1 mole, 1 here produces 1 mole of what? Sodium tetraoxosulfate 6. This 1 mole of this is equal to this. So we have 1 mole Na2CO3 produces 142 grams. That is of this. Therefore, this mole 0.037 mole will give us 0.037 times 142. So let's get the answers. Alright. So in grams per dm. Alright. So now 0.037 times 142 gives us 5.25 grams. Okay, let's get the volume of carbon dioxide at STP that will be liberated in C above. Alright, you know that 1 mole of any gas at STP is equal to 22.4, right? So when you look at that equation, there's 1 mole of this that produces 1 mole of this. Alright, so we'll go like that. So 1 mole of sodium carbonate 4 produces liberates, or let's use produces what? Or liberates any 1 mole of CO2. This is 1 mole of what? Na2CO3 in terms of volume produces 22.4 dm cube, because 1 mole is 22.5. I started to do like this. Now the volume, this mole now 0.037 mole will produce 0.037. That is this times this divided by 1 times 22.4. Alright, so let's multiply 0.037 times 22.4. was 0.8288. That is 0.83 volume. Alright.